Today's lesson, we're just going to talk about quadratic polynomials would be like parabolas. We will eventually be talking about other degree polynomials, but today's just quadratics. So all of these are parabolas. There are three different forms that we're going to have in this section. There's vertex form, quadratic form, and intercept form. The vertex form is a lot like the standard graphing form that we did in conics. This is chapter 2 in the book. We just did chapter 10, so this stuff should be easier than the quadratic stuff we just got done with doing. All right, what it is in vertex form, you'll see there's an a in front, x minus h squared plus k, and then the hk, that's the vertex. We're today also going to find the axis of symmetry. The axis of symmetry is also like the line of symmetry when we have parabolas. There's that middle vertex, and then if you folded the parabola in half, it would be completely symmetric on either side, so that's called the line of symmetry or the axis of symmetry. So I'm just going to abbreviate it AOS, but it stands for axis of symmetry. And then for finding the x and y intercepts, we've gone over finding x and y intercepts, but we're not going to have that in our assignment today. So these notes are also for tomorrow's, Monday's lesson. We're just going to do graphing today, the vertex and the AOS. That's what we're going to cover today. So when it is in quadratic form, you can change the form, but that's a lot of extra work. We want to be as efficient as possible. So when it's in quadratic form, to find the vertex and the axis of symmetry, we have a formula. The axis of symmetry is x equals negative b over 2a, and we get that from the numbers that are in front of the x squared and the x, negative b over 2a. And then you take that number and you put it in the vertex in the x spot, because it's what x equals. Then you plug it into the function to find what y equals, when x equals that number. If it is in intercept form, that means it's factored. That means that we can easily find the x-intercepts if it is in intercept form. I wrote a note right here because my formula doesn't always work. It only works if x is 1x. It doesn't work if x is 2x. So I wrote a note here. Don't just use p and q for this form. Don't just use p and q, but we're going to solve it, and you'll see that when we do it. But this is in factored form, so you would solve to find what x equals when y is 0. You'd find your x-intercepts. The axis of symmetry, once you find those x-intercepts, is the middle. It's the average of them. Average of the two x-intercepts. And then the vertex, you plug in the x part, and then you find the y. That's all we're going to cover from this formula page today. We'll do the x and y intercepts on Monday. We're going to start out by graphing, and all the graphing we're going to do today is in vertex form. All the graphing we're doing today is in vertex form. When it is in vertex form, you have a value out front they call a. You guys remember when we did sine and cosine and we graphed and we had a, b, c, and d? Yeah. So this is kind of like that, only this is going to be less steps. There's an a. There's an h and a k. That's what we have. An a indicates a reflection in the x-axis and or a vertical stretch or shrink. So these parabolas we're going to do are only going to go up and down. We're not going to do side to side. They're only going to go up and down. We're not going to do side to side. So if there is a reflection, it's going to only go down. It's going to be up originally, it's only going to go down if there's a reflection. What makes something go from up to down? Negative. So if a is negative, if a is less than 0, there is a reflection in the x-axis. If a is less than 0, you're going to write the words on your paper, reflection in the x-axis. Okay? If a is less than 0. You'll write those words that I just underlined. Now to tell if there's a stretch or a shrink, you're going to look at the absolute value of A. So we're not looking at the negative positive, we're just looking at what A is. Not negative or positive, just the value of it. So if the absolute value of A is greater than 0, or not greater than 0, greater than 1, it is a stretch. It is a vertical stretch. If the absolute value of A is less than 1 but greater than 0, which absolute value of A would be greater than 0, I really shouldn't have to say that, but if it's less than 1, then it is a shrink, a vertical shrink. You know why we have to say vertical? Say I didn't understand that. Say it again.
So like if you're doing it like horizontal, then like after that of A,
Right. Totally. Because we're doing vertical stretches and vertical shrinks. We're not doing horizontal stretches and horizontal shrinks, but there is such thing as. So you need to say which one it is. Because there is a horizontal also. And yes, everything would be backwards. Okay. H right here indicates a horizontal translation. So you would be writing words like translated. And every time we have parentheses with X in it, it's opposite. And we did this too when we graphed sine and cosine, and there was a period. When we graphed sine and cosine and we did the period and we had that b value, we always had to like divide it by the b value. We always had to flip it. So anything that's in the parentheses, it's going to be opposite. So when I have something like x minus 5 squared, it's actually going to move to the right. Does it translate 5 units right? But we were doing that with conics. Everything was opposite when we found the center and the vertex. It was already like that. Okay, when we have a number outside of the parentheses, that is a vertical translation. And this says plus k, so you're going to go with whatever sign k is. So it's not opposite for k. So if we had out there, if we had like plus 3, this would be translate up 3. So the number outside is vertical translation. And it keeps the sign that it is. It's not opposite, it keeps the sign. So you're going to do 6 graphs in your assignment. On all 6 graphs, I want you to graph the parent function, y equals x squared. You're going to pick values for x that will fit on the graph, and that you can square easily. Yeah, watch how fast I can do it. So 0 is 0, 1 is 1, 2 is 4, 3 is 9. We're just squaring it, okay? That's half of it. So I go out 1, up 1, out 2, up 4, out 3, up 9. And this is a parabola. It's symmetric. So it's going to be the exact same on the other side. Negative 1 is 1, negative 2 is 4, negative 3 is 9. So we go out 1, up 1, out 2, up 4, out 3, up 9. So you're going to first sketch the parent function. It does not need to be a solid line. It's just a reference function. And you are graphing the parent function because I want you to know it. So you're going to practice it 6 whole times. Okay, from there, we're going to use our transformation. So looking at the new function, negative 2x squared, how is that different than x squared? reflection in the x-axis. What does that mean? Yeah, it means it reflects over the x-axis, but the terminology used is reflect in the x-axis. That's the terminology that is used. So when you go to college and you write the words over, and then they say, I didn't teach you the right thing, that's not going to happen. It's reflection in the. Reflection in the. Okay, then the second thing is there's something else different. What's the 2 do? It's a stretch. It's a vertical stretch. By factor of 2. It's a vertical stretch with a factor of 2. So our ordered pairs for our parent function, the reflection in the x-axis, does that affect the x or the y? What's changing if we go from here to here? That's the y. So it's confusing because you write reflection in the x-axis because that's what we're reflecting over, but it's actually changing the y. And what about the 2? A vertical stretch? Vertical affects which variable? It's the y variable. So both of them are affecting the y. We're going to take all of our y's and just multiply them by -2. First one doesn't even fit on the graph. And then just like we did back in trigonometry, we are not going to graph all of this. You're only going to graph the most outside x and outside y. So since we changed the y's, we're not graphing those. We're graphing -2, -8, -1, -2.
Is that a time symbol?
Yeah. Sorry. I like to use that because when I do a dot, people think it's a decimal. If I did an X, people think it's an X. Or asterisk, I guess. So your graph should physically look skinnier and flipped upside down. What's our vertex?
0, 0.
Okay. It does not say to list this, but it does say to do it in the homework, so I'm going over it. And what's our axis of symmetry?
Y is equal to, I mean, X.
It's always going to be x equals for these because they're all up and down vertical lines, so it's always x equals. Now, if we were doing the side-to-side ones, the horizontal ones, then we'd have to really think about which one it is. But these will always be x equals for the axis of symmetry. By the way, if you just tell me the axis of symmetry is 0, I'm taking points off because it's not 0. It's x equals 0. It's a line. So you need the x equals with it. Okay. Oh, let me see. You just said them yesterday.
I know. I was just wondering.
When I have like 8 hours to grade them.
Okay, I just didn't know when I cried. No, I don't want to cry.
Okay, so same thing. Let's start and bust out that parent function. You're going to go 0, 0, and then you're going to go out 1, up 1, out 2, up 4, out 3, up 9. 1, 1, 2, 4, 3, 9. I'm just saying perfect squares. 1, 1, 2 squared is 4, 3 squared is 9, and 0, 0.
Right.
So that's your parent function. Now, what are we going to do to transform that parent function? What's the half tell us?
You multiply it by half, so it's definitely going to shrink.
So vertical shrink
For sure.
by factor of a half. Oh, no. You say you will. What's the -2 say?
Horizontal stretch.
Translate
Keep putting up there.
2 units right, correct, right. And then 1 unit, which way?
Down.
Down.
Yes, I see that was.
Okay, so there's a lot happening here. This might be one that is helpful to have the table. I don't know if we always need the table, but it might be helpful to have the table. By the way, where's our vertex?
0, 0.
Okay. There's going to be a translation, 2 units to the right and 1 unit down from 0, 0. 2 units to the right and 1 unit down.
So 2, -1.
That's the new vertex. Yeah. That's what I'm saying. That's the new vertex.
Like write the new vertex.
You will in your homework. It doesn't say to do it here.
Oh, that's fine.
Homework. You can either find the vertex first because all of your questions in your homework will be vertex form, and these 2 numbers tell you the vertex. So you can either find the vertex first, or you can graph it and then figure out where the vertex is. I don't care which order you do it in. All right, so my ordered pairs. What are we doing first to the ordered pairs? Half of what? X's or Y? Yes. You multiply all your Y's by half because it's a vertical shrink. And it is symmetrical, so once you've multiplied some of them, the other ones should multiply to have the same answer. So it's really like only half the work. After we do that, then we have some translation. To translate 2 units right affects which variable? The x. So that means I'm going to do what to my x's? Add 2.
I thought we've done this before.
We have. That's what I'm saying. We've done it when we need you to do trigonometry. We just did it to like harder things.
So this is going to be easier?
I think than trigonometry, yeah. I think. And then 1 unit down goes to the y. We're just going to take away 1. And then you graph the most outside ones. None of that. You graph the most outside ones.
Gradation.
I'm describing the order pairs that we just wrote in our table. I do not want to see you just plugging this into your calculator and copying the table down and plotting these points. I'm not assessing you on if you can use your calculator right now. Later, I'll assess you on using your calculator. That's not what we're doing today. At least on part of it. So eventually what's going to happen is we're going to get harder polynomials that aren't to the degree of 2. They're going to be like the degree of 5. And you will need to use your calculator at some point. You will need to. But this stuff, you should be able to do by hand. Okay? All right, on the back of your notes, we're only doing 3 more examples. And just like in your homework, it's going to be the same way. You're going to have an equation. You're going to find the axis, symmetry, and the vertex. That's all I'm going to ask you to do for homework today. So to find the axis, symmetry, and the vertex, depends which form it's in. So I've given you all the forms on the front page. You might have to flip for now, but which form is this one in? The vertex form, so we can find the vertex first. What's the vertex?
4, 5. That's good.
The axis of symmetry is always x equals, and it is the same as the x that the vertex has. So x equals 4. And we're done. So that question.
Alright.
Okay? Vertex form is wonderful because it gives you the vertex and the AOS. Next one is this vertex form.
No.
No. So we can't just look at it and get the vertex. So now we're probably have to do a little bit more work for this one. It does have the formulas. I'm going to write them up on the board so you don't have to keep flipping. But it does tell you first we're going to find the AOS. It says it in order. First we're going to find the AOS. And the AOS formula is x equals negative b over 2a. And that negative b over 2a, if you're looking ahead at the next example that we're going to do on Monday, is part of the quadratic formula. You see the negative b over 2a in the quadratic formula? See that? So it is part of the quadratic formula. You've seen that kind of thing before. All right, so what are we going to do? Negative, what's b? 1 over 2 times, what's that? Negative 1. So our axis of symmetry, x equals a half.
What is B? Oh, no, I'm like.
This is ax squared plus bx.
Bless you.
Then what we're going to do is we're going to find our vertex. And in the formula, it says the vertex is an ordered pair where the x part is negative b over 2a. And then you plug that into the function to find the y. So f of means plug that number into the function where x is. We're going to take our function f of, we're going to plug in a half. So we're going to do negative 1/2 squared plus 1/2 minus 4. Order of operations, you will square what's in the parentheses first, then do outside the parentheses the negative sign. So we'll get negative 1/4. Negative 4 plus 2/4 minus 4 is negative 3 3/4. So our vertex is the ordered pair, 1/2, comma, negative 3 3/4. Okay. Last one is in intercept form, which is like factored already for you, which we've factored in here a few times this year. We're going to continue to do it. This one's already factored for you. So what we need to do is we have to find the x-intercepts to be able to find the axis of symmetry. So quickly, how do you find x-intercepts? Always, forever. 0. For what? For what? So if you want to find the x-intercepts, you make y 0. So f of x is y. We're going to make that 0. And then we have 0 equals all this. So to find the x-intercepts, we take each factor that has an x in it and set it equal to 0. The negative 3 is not going to affect my x-intercepts. The negative 3 tells me how skinny it is and which way it's flipped. Okay. So I'm going to say x minus 9 equals 0 and x plus 5 equals 0. This is to find the x-intercepts. So x equals 9 and x equals negative 5. Now why I needed to define those? I know that I'm going to have a graph that is flipped down because I have that negative sign in front. And it's going to pass through negative 5 and 9. I need to find my axis of symmetry and my vertex, which is right in the middle of those two numbers. It's going to be right in the middle of those numbers somewhere. So to find the axis of symmetry, you're going to average 9 and negative 5. You're going to average your two x-intercepts. And I get that my axis of symmetry is x equals 2. So we define our x-intercepts so we can find the middle. And that's our axis of symmetry. And how do we find our vertex once we know the x part of the vertex?
You plug the axis of symmetry value, so x is the equation.
So we're going to do f of 2 So we're going to do -3 times 2 minus 9 times 2 plus 5. -3 times -7 times 7, which is 145. So our vertex is 2, 147. Okay, that's all we're going to do for today's lesson. So our assignment is a worksheet that I created.
What
So
was the vertex?
147.
2 of, never mind.